Beautiful place.
Yeah, it's foggy today. Normally it's like a very nice
Start with, so the way it's going to flow is like, we'll be Jeremy and I kind of just like, hey, what up? And then you'll put a big do you know how long your presentation is? Okay, perfect. Let me know what you want to present. Can't really think about this part.
I should drop it on Andrew's. I need to plug that.
I really like the academic part.
I feel like I'm really ready now. We'll give a lightning talk about my progress. It's the back corner. Your jacket. Yeah, it should be. Oh, is it not? Oh, is it not? Is there no one to yeah. One word? Yes. Yeah, I think यहाँ पे जो था इसको उन्होंने कर दिया हैंडपुट कर दिया यहाँ पे
I can't really tell what there's nothing important to be about what's coming up. And I said, let's put you later until you I said, later.
ये बहुत ही खराब है इसके ऊपर जो वाला प्रेशर है इसलिए आई वेरी 100 वेरी ओवर गवर्नमेंट नंबर से ऐसे भी करा बहुत गुड आ गई it's similar to DPO
Well, now it's disconnected. Hey, Jeremy, could you just plug it in?
In fact, DPU was better on the models than GPU. XPPU was better than DPU, but it was similarly. ऐसे बिल्कुल नहीं करते हाँ but ये other results, but I think but the point is, look, it gives you one push it because people need to break independency. That will also look at results. You know, I never listened to Welcome!
Welcome to the NeurIPS Research Hackathon! Woo! Woo! Such a joy to run this grand experiment with you all today. The intent is to launch over a dozen research projects, research papers, replications, open source code bases of new research ideas. And you all have been hand-selected as capable. So do look around, make friends throughout the hackathon, and create something creative and novel. And so my name is Jeremy. It's not clear to me whether this hackathon is possible, because research is the kind of domain where you need deep thinking, where you need a lot of creativity and time. And in the context of a hackathon, the aesthetic is ship, right? So, 1 p.m. to 8 p.m., you have 7 hours to create something, and that creation's usually this manic rush. And so we are gonna try to find out whether or not we can come up with a novel idea, get an implementation, and then demo it at the end of the day. My hope is that if it succeeds, we've sort of discovered a new way of creating new ideas, creating new projects with friends, and hopefully connecting over research creation. So, super briefly, there are 3 major types of shipping today. So one is a re-implementation of a paper. So think back to a paper that you've always wanted to understand more deeply and code it up. That kind of demo would be very valuable, and if you open source that code, other people on GitHub and the research community can collaborate with you on it. A second is a new machine learning research project. So you have some creative idea, some instinct, and you can step up and give a lightning talk about it. We'll have space for people to basically coordinate and find teams. But the hope is that you and some people at this hackathon can launch your new ideas, and so perhaps the next DPO will come out of some creative instinct that you've had over the last few months that you implement here. And finally, I think we all have some projects that we haven't written up and that we perhaps hate writing up. One thing that you can do is write up an existing project in the format of a high-quality research paper, so that in this 7-hour sequence, you can basically apply to a workshop or basically come with a nice public representation of what you've been working on for a long time, and take advantage of the sort of social structure of the hackathon to be a commitment device to making the publication happen. I have a lot of love for AGI House. We started quite a long time ago now, so September 3rd, 2022. I kind of think of this as the PayPal mafia of AI. So this is my roommate, Andre Karpathy, Kyle Morris, who's standing next to me, Marco, who helped co-found it. But what's really cool is, so Arvind Srinivas, the founder of Perplexity before Perplexity even existed. This was back in September of 2022. Is here, the founder of Lamini before Lamini existed, a good friend Sharon Zhou, and Sheriff, the creator of Lexica. So Lexica was actually blowing up to millions of users when this photo was taken. Basically, the house has a storied history of launching incredibly impactful projects and connecting people who are doing really deep and profound things. And so hopefully, if we take a photo at the end of demos today, we can look back years later and be like, oh, no way, I met the author of such and such back before they were great. So have a lot of fun with your friends. I think it's gonna be a great community. Super looking forward to it. So now to jump into our main presentation, there's a lot of love for our speakers. So Raphael, who authored DPO, recently shouted out on Twitter by Andrew Ng. He said, "It's only rarely that, after reading a research paper, I feel like giving the authors a standing ovation. But I felt that, but I felt that way after finishing direct preference optimization by Raphael and his co-authors. This beautiful paper proposes a much simpler alternative to the reinforcement learning from human feedback set up for aligning language models to human preferences." And he goes into detail, but I think it's worth giving Raphael a quick standing ovation. So if everyone can stand. Congratulating our speaker to be. So we'll have our sponsors speak as well. Super quick, we're gonna have speakers, and then you guys will speak about the projects you want to create. We'll have hacking for 7 hours, and then we'll demo everything at the end of the night. The Wi-Fi password's attention is all you need if you need it. If you're not in the Slack or in the spreadsheet, check your text messages. You should have gotten a link to them. We'll be using the Slack to coordinate, lunches here, dinners here. You have some idea, you can post it and people can talk to you about it. Spreadsheet with lightning talks is open as well. So after our speakers speak, you guys will come speak, and if you have an idea, please do put it there. And finally, we're going to be demoing at the end of the day. Hopefully, there are a number of glorious creative ideas that have been burst into existence. But with that, Let's set off speakers and give a huge round of applause to our new speaker.
Should be good. That did not seem to. Sorry about that, guys.
You look like really like similar. Exactly the same. That's good.
Alright, sorry about that, guys.
All right, it's gonna be
Alright, so I'm gonna just kind of go over what DPO is, what it does, why is it useful. We gave this talk to an audience at NeurIPS, so it might be a little bit more technical. I'll just kind of like briefly go over these parts just so we're all on the same page, but I'll also talk a little bit more and focus on what you can do with this and like why is this kind of like be making the rounds and become more popular. Fundamentally, DPO is a way to solve the ROHF problem, which is like reinforcement learning from human feedback. And why is like RO from human feedback kind of important? Like, I mean, if you haven't like seen that, it's basically like it's the major component that took us from GPT-3 to ChatGPT and GPT-4 and beyond. And my thing about like where ROHF comes in a lot of systems, not just language, but beyond is, you know, the base model will give you knowledge, the base model will give you understanding, instruction model will give you capabilities. With just simple autonomous driving, that sort of gets you about 95% of the way there. And you can do a lot of things with those 95%, but to really like hit that stage where you have a product that's useful and you can do a lot of things, you need those 5%. And you can't really get to those 5% without like basically this reinforcement learning stage for a variety of reasons that, you know, I won't necessarily go into. So basically, what did OpenAI do to get us from GPT-3 to ChatGPT? Like, what is this, you know, whole ROHF thing happening? So ROHF assumes a particular form of feedback. So you get your base model, your, you know, instruction tune model, SFT, and you take a bunch of prompts from users or, you know, the things that people care about, and you ask your model to generate two completions, basically, two possible answers. And then you would ask a human grader to like compare those two and tell you which one's better. You would then use that data of prompts and potential answers to train a reward model, basically like predict how useful this answer is to the human, how likely is the human to agree with this answer and you know, be satisfied with this answer. And then you take that reward model and plug it into a very large scale, hard reinforcement learning algorithm to get your final model, to get basically your ChatGPT. So the first step of the reward model, how that works is, basically as I said, you assume a data set of preferences, you have prompts, you know, users have submitted, you have potential answers, and then you have preferences or rankings between those answers that your users you're providing. You then use a parameterized reward model, which is basically another transformer with the final layer removed. You start with the instruction model, you remove the final layer and add a basically linear predictor on top to predict the quality of the response. And you train it with this equation, which, you know, from behavior economics, whatever, it's like the Bradley-Terry preference. It's known as the Bradley-Terry preference model. It's what's been used in the OpenAI models before, in the Anthropic models, et cetera, et cetera, et cetera. Once you have that basically like reward model that, you know, takes your prompts, takes your answers, and predict the quality, how likely are those to be useful to the human, you go into the RL phase, and that's kind of like the painful point. Basically what the RL phase does is you're trying to train a model. Your model becomes a policy to maximize your reward, which is the first part of this. So you want to generate answers that are maximally useful to the human, while not deviating too much from your initial model. And this is important because your reward model, essentially like predicting how useful your answers are to the user, is fundamentally trained on data from that model. So you can actually, like, if you deviate too far, your reward model becomes inaccurate. And basically take this equation and just plug it into essentially what OpenAI has been using and Anthropic is using is PPO. The goal of this is not to understand PPO, the goal of this is to understand that PPO is hugely painful if you don't want to deal with it. It's to implement it correctly, it's like 20,000 lines of code and about an order of 100 hyperparameters. So yeah, that's kind of where we started. It was like basically when we started this, we knew ChatGPT existed. We knew this was possible. We knew this was a necessary step, and we knew there are huge benefits to be had from this. But back in May, when we started working on this, I would argue outside of the big companies and the open source community could not get this right. There weren't existing ROHF models that were efficiently really pushing the line beyond instruction models. And that's not because of fundamental lack of, we knew the recipe, but the technical application of the recipe, like how do we get all of this right? How do we get all these 100 hyperparameters right? Like it just wasn't there in the open source community. And I would guess like it took OpenAI when they first started doing this, like years to actually probably like really nail these points. So this is kind of like where we started from. We want to develop an algorithm sort of from first principles, like really makes this ROHF phase possible, which is where basically our reference optimization is. I would probably not go too deep into the math because I'm assuming you don't really care about this, but the key idea here is whatever you're trying to optimize for, whatever reward you want, whether that's like code correctness, whether that's usefulness, whether that's trustworthiness, whether that's factuality, there's a correspondence between models and that reward. So a model induces a reward, and a reward induces an optimal model. And that's a mathematical equivalency between the two. And you can basically like take that mathematical equivalency and plug it back into your reward training function, and essentially parameterize your reward in a certain way that gives you the exact optimal way to extract your policy from the RL problem without doing RL. So we can mathematically get the optimal RL problem without even touching anything resembling it. And that's really that. Like that is all DPO is. It's basically as simple as supervised training. It's a classification problem. You have your data, you have your preferred answers, you have your initial model, you have your least preferred answers, and this like single classification loss is what you optimize. It's quite literally, 40 lines of code altogether compared to the thousands of lines of PPO. So you can take this like complicated multi-step process and just like get rid of everything and just essentially fit that one supervised loss. And that's kind of it. That's basically like there's some more understanding here, but you probably like without this you need to go through this. But yeah, that's kind of all there is to it. That's I think that's what the community really like. It's like really simple then results. And we tested this on a bunch of open source stuff. Just mechanistically, we find it to be a lot more efficient as a training algorithm than we tried TRL, we tried TRLX, which are the open source ROHF libraries that the people have used. Just mechanistically as an optimizer, it's a lot better. It gives you a lot better trade-offs on these trade-off curves. We tested it on basically the open source summarization data sets that we had back then, and just performed just as well as everything else. We also, okay, so this is actually a good experiment. One major point that people have raised is that PPO generates a lot more data. You can query your model a lot more and get feedback on a lot more data. Versus DPO just trains completely offline on the data you already have. And there's a question of like, is this going to generalize just as well? And we actually did this experiment where we trained for summarization quality on summarizing social media posts like Reddit posts, which is the classic TLDR experiment. And we then took those models and asked them to summarize news articles. And there's obviously huge degradation because of the the distribution shift between the training and the evaluation data. But basically, they degrade in the same way. It's not, there's no really difference in generalization capabilities between PPO and DPO. So as far as we can tell, this is kind of the main argument that like has been coming out of like different areas where, classic RHF allows you to train a lot more data and generalize better. That's not something we've seen so far. And I think remains to be seen. But I think like, everything besides this like simple experiments, I think the really strong points of, like taking up this algorithm is like basically what the community has done. And this is just a small sample of things that people have trained with DPO. all of these models use DPO. I think if you go to the community, go on Twitter, look all the new open source state-of-the-art models, like a lot of them in one way or another have touched that model, whether they're like merging models that were trained with DPO or the self were trained with DPO. That's kind of become the go-to to the open source community. I want to particularly point out the Mistral models, which have been doing really well. And actually, we can quickly chat something. How many of you are familiar with the Chatbot Arena? All right, cool. Well, the Chatbot Arena is like an open source project where there's like a bunch of large language models. Bunch of large language models and users, general users. Yeah, so you can see that. So a bunch of general users like vote on those, like in a blind voting. You kind of see that the Mixtral medium model is like pretty close now to GPT-4, and the Mixtral model, which is basically the well-known 8 mixture of experts model, is actually like outperforming Claude 2.1 and Gemini Pro. Which, let me just point out the Mixtral was trained by like 10 guys with like open source data, and there's like, if you ran the Gemini paper, there was like close to 1,000 authors on that. Just like, just so you know. So yeah, I think that's kind of like been really why people have like this, and I think this sort of development has allowed the open source community to really close those like last 5% performance gap between being able to do ROHF and being able to really push the instruct models in those last 5% performance, and being able to match a lot of these closed source models as well. So there's a lot of things you can do. You just go on Twitter and like, look up DPO like and see what people are doing it with all sort of applications, whether it's like code, creative writing. There's some questionable applications of this as well if you dig deep into Twitter. And yeah, I think whatever, it's a really efficient way to give feedback to your models and train them that way. And yeah, I think there's a lot to be done here, a lot of things to train. And I want to also quickly plug in some other things. If you're interested in seeing this, I'm going to refer to Twitter as a source of great research results. Basically, we developed the DPO for diffusion, text-to-image diffusion models, which I'm not going to go into because it's actually like a quite involved mathematical algorithm. But basically, we took an open source stable diffusion XL, we trained on a bunch of open source data, and basically we got it to slightly outperform Midjourney on blind human evals. And that model is now open source, by the way. You can go like find that on Hugging Face and just like download it and just like start playing with it. This paper is on archive, you can check it out, like the model's open source. And the final point to make, all of this is actually also like really easy to use. Like you can check the DPOs now implementing transformers. We have a public FSDP code base to use, which is really easy to use. Intel implemented in their like scaling library up to 1 trillion parameters supposedly. So we have like a lot of implementations that are really easy to get started with. And they have like a pro data sets. I think at this point it's probably like over 10, 20 data sets out there that you can start playing with. And the diffusion stuff has already been implemented in diffusers as of last week. So this is also open source, both code and models, if you want to start playing with it. So yeah, that's all I have. If you guys want to talk more about it, happy to. There's a lot of ways we're trying to push this further. We have work on vision language models coming out. We're trying to adapt this work to agents in the near future. So pretty excited to chat more about this. And sorry if I went a little bit over time.
You're good. Yeah, space for 1 or 2 questions.
Yeah, I'd love, so like the research is incredible. What can you describe a bit the process of the research? Like like where did this glory emerge in the like?
So actually like I started working on this project. The idea there was actually about text detection, so machine-generated text detection, and can we use, a reinforcement learning red teaming attack against machine learning text detection? And we use a lot of the public open source code bases for RL, like TRL, TRX, and that didn't work at all. Like it just, like the model completely, it didn't produce any more human-like text. It just completely degraded into nothing. And then we started like exploring ways to make that more efficient, exploring these like reinforcement learning algorithms. And there's like a lot of mathematical background of starting from particular reinforcement learning algorithms to deriving this, which I'm not going to go into, but basically we're looking into a lot of like offline type of algorithms. And that's kind of like where this happened. And just so you know, after we did DPO, we also finished that project and we showed that you can train open source models to generate text that all open source and all commercial detectors judge to be more human than the average human. That's a paper in submission currently. So.
Did you guys have like the intuition about the math and then derive it? Like you tried it and it worked, or were you like deriving a bunch of things trying to find a better solution?
So the math came first. We first derived the math, and then basically we plugged it into this problem, as I said, of basically fooling text detectors. And at this point, nothing could work. Like none of the open source RL problems and libraries could work for that particular application, for a variety of theoretical and practical reasons. And we just tried like literally the first experiment we run on these text detectors, and it worked great. And then it was like, okay, we have something here. And actually the whole thing was done in like 3 weeks before NeurIPS. From the point we derived the math to like NeurIPS submission, it was like 3 weeks.
So you just recommend because like everyone's trying playgrounds and stuff right now. You recommend we just kind of like get the math, like just crack open some math textbooks and be like, let's just like.
I think it goes both ways, right? I think it depends. Sometimes like practical search yields things that are better, and then you kind of like try to justify them. Sometimes mathematical things yield things better and try and justify them. Like diffusion first started from like a very sort of deep mathematical understanding, and it took like a lot of practical work, for example, to get it to the level it is today. But on the other hand, we've had like things that sort of work in practice and then sort of hand wave why they work. So it goes both ways.
The data you generate for preference data, that's usually generated from a reference model, but like the reference model becomes fine-tuned using DPO or RLHF. But after some point, do you see gains if you generate again the sample data from like again more preference data which is good and bad, and then do the same process again, like multi-step?
Yeah, getting continuous feedback that is probably like can really boost performance. So that's, for example, what Llama 2 did. So they actually did like 7 rounds of ROHF or something, where basically like collected some data, or 5, I don't know if you're 5, 7? I don't know, you're like shaking your head or something.
No, I don't know the number.
So yeah, for what Llama 2 did is they collected some data, trained with ROHF, classic ROHF, took the new model, collected more data from the new model, trained again on that, and did like 5 rounds of that, and that improved performance. Right. So if you're able to get more data and get like high quality feedback, you can just do this like for a long time before you like saturate probably. Right now I think this made the whole process like feasible and easy. I think right now the biggest bottleneck about like improving these models is getting like feedback data efficiently and at scale.
Could you speak to the difference between direct reference optimization and KTO?
Yeah, so KTO comes from a particular like idea about behavioral economics and things, and the idea there is you can probably use like binary feedback, so thumbs up, thumbs down, which you cannot do here. It seems to work in practice, but actually if you dig into it, it's not mathematically consistent, and that makes me think that there's applications where it will not work. For example, I think like if you do things like the OpenAI process supervision paper, it will not work there because, for example, the assumptions they make to make that math give you something work around are not necessarily realistic and a lot more complicated data sets. So I think that's kind of like one thing. It seems to work in practice for a lot of like chat data sets and things like that. But yeah.
Amazing. Next up in briefing of Dilgard from Montreal. Presenter.
Maybe intro.
Where's your I use the
I feel like this.
Yeah, so
Okay. So for context, DivGarg's currently running the premier agent automation for the browser company.
we don't have data for it.
Let's hear it for Div.
Oh yeah. Good. Yeah, thanks everyone.
And speak up.
Okay, cool. So unfortunately, I had a bit of a cold last week, so my throat might be a bit sore, and that's why I'm doing a thick jacket. But bear with me. And so like, okay, let's start. So I'm very excited about like personal AI agents. Like you have seen so much hype about agents already in the beginning of the year, and there's like so much stuff that's already happening. And I think like the reason there is because everyone really knows like this is the future. 2 years from now, a lot of the world will transition to where like everything won't be like everything's almost like a solo experience right now, where you have to do things alone and like you have to like find all the hard things that happen and like do a lot of hit and trials and like solve that. But what's going to happen is everything will become a collaborative experience where you will have another agent that's sort of helping you out, find like all the holes that are there and like sort of like helping you with them in your daily life. And you're already starting to see that in coding, for example. So if you have like IDEs, okay, got it. So if you have like IDEs like Cursor, for example, it's already like programming has become a collaborative experience. So that's sort of starting to happen, and that will start to happen in every single personal things that you can do, which could be said from like your daily habits to work life to like social life, everything else. Cool. And let's see, I can show some demos. I'm not sure if people have already seen this demo, but this is sort of the first flight booked by an AI agent, where we had it go to Google Flights and book a flight from New York to SFO. It's not very visible, unfortunately. Let's see. Yeah, I might just move this a bit ahead, just because it's not too visible, but yeah. But the AI is actually very powerful, so it can go actually select seats for you, it can also check out for you. And so it has like purchasing power, which makes it very unique in terms of what you can imagine is possible. And I'm pretty sure like by later this year, we'll be starting to see agents being used for e-commerce, for like flights, for like a lot of like everyday activity. And that's gonna be like a very interesting transaction where like now you are not a solo person like responsible for all your like everything that you're doing. You have another agent, and then you're sort of delegating tasks to that agent, and you might be giving a budget to that agent. Like, okay, there's like $1,000, and like here's I want to go to Italy. Plan my itinerary, like book everything for me. Cool. Yeah, and so it's really exciting, like what you can do by agents, especially I would say like I would call them like human-like agents, because it's very easy to train these agents. They are operating interfaces that are made for humans, and that's why they can generalize to anything that a human can do. And that makes it also like really interesting that there's almost no limitations of what theoretically like this could enable. And so like I would say like the LMs are the present, agents are the future. The future is all nearly here. But the question then becomes like, how do we build a safe future? So how do we make sure like the agents that we build and are like start using in everyday life, they don't start taking control in a sense. Like you still have the decision power. They are doing things for you, but they don't end up making the decisions for you in a sense. And how do we deploy this agents at large? Especially because they are stochastic systems, they might still make mistakes. So how do you ensure like, okay, like if there are failures, the failures are not harmful. You don't end up booking like wrong $1,000 flights for people and like not cause like chaos in society in a sense. And so that's gonna be like a really big problem to solve. But also like one thing that makes it like a very exciting space to be in. Yeah, and this is something that we're trying to solve at my company, Multion, where we want to build these agents that are running and doing tasks for you in the background. It is part of your digital experiences. And I can show like a live demo. So we have been doing a lot of exploration around like how can we boost our agent capabilities? Like how can we have our agents do like very complex tasks? So here's actually like a really complex task. So I told it like, okay, like go to Twitter search for the last tweets I made, checking the last 10. Remember then you can go search for super interesting, so remember that, and then go search for super interesting AI news. Search the news for up to 3 different sources. If you see the source as not really interesting AI news, or I already made a tweet about that, then go to a different one. When you finish the research, go and make a small interesting AI tweets with the info you gather. Make sure the tweet is small but informative and interesting for AI enthusiasts. And like we gave it like don't make more than like 5 tweets. So this is like a really complex problem. And so we have been like experimenting a lot over like the winter break about how can we do like better planning, how can we do like subtask composition. And so this essentially involves like more than 20 subtasks. But the agent is actually now able to go and do that. We'll just okay.
I'm clicking on the profile link to view the user's last 10 tweets. I'm scrolling down to view more of the user's last 10 tweets to remember them before searching for new AI news. I'm scrolling down to view the remaining tweets from the user's last 10 tweets to remember them before searching for new AI news. I'm navigating to Google to search for the latest AI news, which will be the first source of information for creating new tweets. I'm clicking on the News tab to view the latest AI news articles and ensure that the information is fresh and relevant for creating new tweets. I'm clicking on the first news article from Investors Business Daily to read more about the latest AI trends and top AI stocks, which could be interesting content for. I'm scrolling down the page to view the content of the article on AI trends and top AI stocks, which may provide interesting information for new tweets. I am scrolling down to continue reading the article for more detailed information that could be used for creating tweets.
My 24 webs, but that's it. Okay, I'll send back to Twitter.
I'm navigating back to Twitter to compose and post new tweets based on the AI news gathered. I'm typing the first tweet based on the memorized information about AI reshaping industries and the trend of companies labeling themselves as AI stocks. This tweet is informative and interesting for AI enthusiasts, highlighting the importance of discerning genuine AI innovation. I'm typing 4 additional tweets based on the memorized information from the AI news article. These tweets cover various aspects of AI, including investment tips, startup trends, tech giants, instructions to not exceed 5 tweets.
And now it's correcting itself. Now it's
I'm
realizing.
clearing the input box that exceeded the character limit and retyping those tweets into separate boxes to ensure they are within the 280 character limit and ready for posting.
That's still accelerated, but okay. Oh, it keeps trying. Let's see. Oh, I got it.
No.
Yeah, I think it needs better math. It doesn't know what to it use.
Would it upgrade you to premium on its own?
Please review the tweets based on the AI news research. If they are satisfactory, let me know if I should proceed with posting them.
Yeah. So we're very excited about like what you can enable with this kind of agents, right? So this is like almost crazy. Like this had like so many like contexts gathered. It's its own research assistant. And then we are working on a lot more cool things we'll be releasing like later this month, like this, where we can now compose maybe like work across 20 different apps together, combine the information, bring that together, and do a lot of complex tasks for the user. So that'll be fascinating. So thank you.
Amazing. And in general, my sense is agents are a great research subject for a hackathon context where you have 7 hours and you want to get something that's functional and very cool and demoable. Small developer, I think, was written in a single amount of time. So. Okay, so we're going to have Helen and David.
You want her first?
Yeah.
I'll go first.
So they both made this research hackathon possible. They're our sponsors.
Thank you.
Much appreciated.
Thank you. And Jeremy, I have to say, I almost feel like I should bring my laptop here. I felt like David's presentation was half done by machine, not by humans. So that was a great thing. I'm a bit of an outsider from East Coast, and but thank you for Jeremy and Kyle and Gatsby that I have an opportunity to be here. Super excited. Been here for 5 days, and I have to say it's a very different vibe coming from that side of the house. I don't have a lot to share. Afterwards I can, but here I just want to maybe offer 2 observations and 1 suggestion given the background. I started my own company called Invest 21 with Alpha Copilot, try to revolutionize Wall Street. But I spent most of my time, the last 3 decades, pulling my hair out on JP Morgan as their CTO. So perspectives are all from there. The first observation, I just felt like about a third of the population I see here are dropouts. That's pretty amazing. And I felt like my son's 18, he's in the crowd. I almost want to tell him to do some of that stuff. Maybe that's the way to do a career. And the second thing I want to say is that 50% of the population here are speaking way too fast. I can't catch a single. It went over my head just like that. I don't have a lot of hair, but it's just a zoom. And I want to say third is that I want to say 80% of the people here are founders. At the tender age of 21, and I was goofing around in college by that time. So that was some of the superficial observation. But I want to say that on a more serious side, the dreamer-like passion, the can-do attitude, and that the sky is the limit, and the speed of developing is just amazing. I mean, I hired must be 3,000 people in my career, 30 years, and I have rarely seen this level of passion and energy and dedication. So a shout out to you guys. I do come here every year in spring. In JP Morgan, we have a CTO trip every year here from the West Coast, all the way from Seattle to San Diego, just to see all the big companies. But we're talking to leadership in that company. You don't get this vibe, because this is actually ground zero. So thank you for letting me to be here. And the second observation I want to say, maybe just a bit of PR for East Coast, predominantly for Wall Street. And just for all of you who doesn't really know that part of the world, there's a love and jealous relationship from that part of the world to here. Love that we know that there's so many talents here, and jealous is that you're all here. So it's like stupid. And I've been pulling my hair out just to make sure that we can actually hire some people from here to there. It's part of my mission here. But having said that, on that side of the world, there are 160 trillion, that's a T, not a B, to be managed. And a $2 trillion revenue worldwide. And about $320 billion fintech spend. The use cases are immense. It's a lifetime for everyone. JP Morgan alone, I'm not PR for JP Morgan, I'm out, it was 5 months ago, retired to pursue my dream. But JP Morgan alone spent $11 billion on technology, 60,000 technologists, about 2,000 PhD in AI. But they're not in the epicenter of AI. So I want to see a bit of a cross-pollination of you guys going there, because the use case, the funding, the richness, the problem you really try to solve, a lot of them are from there. So it's not technology solving for technologists for technology's sake per se. So just a bit of education. I'm happy to talk to you guys offline. I'll be leaving tomorrow morning, but anybody who is interested in that world, love it. So my suggestion on the tail of that is Luke eastbound. And I'll be here to help. That's it.
Thank you. And Helen from Founders X, other sponsor. Thanks so much for that.
And one thing I want to say too is if you don't get a chance to talk with Helen or David, talk to Jeremy around. We're happy to put you in touch and keep the thread open, so you're able to both focus on code and also talk to we haven't really hyped up the speakers, but there's a lot of really big ballers here that we're just kind of casually letting them talk. So Helen's another one, so please take it away.
Great. Happy New Year, everyone. Glad to be back. Last year, we hosted 2 hackathons with Jeremy and AGI House. We really enjoyed it. So this year, we're going to make permanent sponsorship for the AGI House to go forward. And we're happy to sponsor as many hackathons you want to do. We just love it. So our fund, we are one of the first AI native fund, Founders X Venture, right on Sand Hill Road, not too far from Sequoia. Started in 2016. We have a few unicorns which are also AI native. So we have seen how things evolved from the small model, right, computer vision, large language specific model, to today, large language models. So we are pretty excited about it. So right now, our immense focus is backing the top 1% founders in GenAI. We're proud backing David, startups Alpha Copilot, even though he's not a GenAI person, but he can easily put a top-notch GenAI team together. What we're looking for, right? We're looking for founders who are really driven to solve a big problem, right? There's plenty of big problems to solve in Wall Street. We also have tons of problems to solve in healthcare, in insurance, and in education, everywhere. So that's what we're looking for. I made a suggestion on this hackathon. Say, I sent one of my team member went to the NeurIPS, and she came back pretty excited. Her name she came back pretty excited. How we need to look into all the breakthroughs in the model. That's why I suggest for this hackathon we start a new year. How about we look at the breakthrough models, including those presented in NeurIPS. But on the way here, I was every day now I chat a little bit with Grok. So I'm asking Grok, say, what are the new breakthroughs in the model? The first one came out, DPO. So I'm glad. I've got to listen to her. Thank you for sharing it all. It's kind of amazing. Then actually I want to share just very quickly, Grok wrote a poem specifically for this hackathon. Allow me to share with you. So I said, I'm sponsoring this AJ hackathon. Could you write something for it? So she said, okay. In a world of bits and bytes, we gather here with our AI might to hack and code and create a future where machines and humans are in sync. It's true. We'll build a world of AGI where robots and humans can live in harmony. A world where intelligence is shared and AI help us to be more prepared. So let's put our minds to the test and build a future that is best. And in this room, we have the power to make AGI a reality, and that's the finest hour. So what do you think? So I thought, wow, this speaks to the hackathon exactly. So that's all from me, and I'm happy to stay here for another hour if any of you want to talk. We mostly we have two part of investments. One mostly do with seed and A round. We tend to write the first VC check into a seed stage. We lead seed a lot. We also do A round, lead A round. Then selectively, we also have fun to do B round, lead B round deals. So we led 2 last year. About to lead another one our portfolio company about to raise a large B round. It's going to be the news next week with a major partnership with Microsoft. You're going to see us a little bit in the news. So happy to chat if any of you want to talk. Okay, thank you.
Okay, it's time to turn the hackathon over to you all. So if you have a glorious idea, please do add it to the lightning talk section of the spreadsheet. We're going to go through the people who have already added themselves as speakers, and after, if you just want to step up and give a quick speech about what you're intending to create, do it. So, Swash Sankar, are you here to discuss your idea?
I am here,
Yes.
but I didn't.
Is it
Okay,
1
I'm
minute?
happy to come.
Yeah, come just jump up. Let's jump.
And just know we're doing these are 30-second, I'm
Right,
doing
right.
X, do you want to team up? And kind of, so
Yeah.
you don't need slides, this isn't a huge, yeah.
Do I have to show anything or just?
No, it's literally just you have a cool idea.
Yeah, describe
The
your
point
idea.
is to get you to help find other people who might want to work with you on a project.
Yeah.
So it's just idea pitch.
Borat, you're on down.
Okay, hey everyone, I'm Aishwarya. I haven't thought this through yet, but essentially what I've been working on for a while right now is kind of helping engineers, etc., go from 0 to 1 on large code bases. So we've worked through a lot of initial stuff, but right now we're kind of building an agent that come up with an entire plan, and you just kind of go through it, and it generates diagrams. We've been working a lot on integrating LSPs, which is static analysis of code, with LLMs. And then it kind of figures out the best way to understand all the dependencies and how to walk through the code base. So yeah, we have a product that's launched initially, but there's a lot to keep improving. So So if anyone's interested, I'm Aishwarya. Yeah.
What? Yeah, you're up. No, just sign up. Okay. So I'm gonna go real quick. So what I want to show you is a very quick way to potentially turn existing projects that you have into a research paper. So this morning, it's kind of for fun, I put together this paper. So basically, it's, the paper is a NeurIPS inspired research hackathon, bridging the gap between research and industry, by Kyle Morris, myself, and Rohan Pandey. Clearly formatted in the style of the NeurIPS 2021 research paper. Yeah, Kyle got first author.
I didn't do anything. So.
And it's simply out of a Gen AI research paper creator that my company's put out. So it's free for the peeps of the hackathon. Just go to omniscience.tech/research. And the setup is basically prompt to research paper. So you describe whatever it is that happened. So actually, the research paper here was created from the particle description of our hackathon. So I just copy pasted the particle description in, and out came, and I guess I should find where's the GTF? So yeah, basically description in, paper out. It's actually like relatively long. It goes into event organization, types of shipping that are allowed, replication, research project, research paper, the importance of shipping and demoing, bridging the gap between research and industry, leveraging social proof, product adoption, et cetera. And then it like walks through the hackathon schedule. Everything's in NeurIPS paper style. So basically the idea is you can style all of the results that your paper has, all of the ideas, and plus it in it, create a lit review automatically using this book. And so if anyone wants to try this out and use it, I'm happy to collaborate with you, and I'm going to be improving it so that basically as people submit GitHub projects, we could, for example, auto-gen the entire hackathon's papers from the GitHub repos, where a model will look at all your code and decide what's novel and interesting and write it up. So yeah, let me know if you want to try it.
Did we get it in PDF or LaTeX?
Both.
Well prepared.
Okay. Jake Seagal, integrated memory model.
Hello, I'm Jake. So integrated memory model is sort of a architecture that I've been working on for like the past couple of months. The idea behind it is essentially allowing for AIs to have a sort of persistent like brain state, so which essentially allows it to essentially remember stuff without having to reread stuff with context windows, essentially by going and sort of propagating a latent space through the different forward passes. The hope is, and from my experiments, it seems to allow for essentially the current efficiency and like of AIs without actually having to have almost any context length. So yeah, thank you.
So that's the integrated memory model. Mark, are you here?
Okay,
And
hey.
again, you're on deck. Oh, sorry.
Oh.
Go ahead.
No, you're good, you're good. So during the course of this hackathon, I kind of want to build on top of the learning platform that I've been working on. But basically, I think it's kind of sad that the way we learn on our own is very curiosity driven. You ask a question, then you dive deeper, then you find something interesting, you keep asking questions and keep diving in. But where you learn in school, it's this very structured content. You can't kind of drive into your curiosity. I really want to explore the TOT framework. I don't know if you all read that paper, but basically you use brainstorming, a bunch of different directions you could go in, and then evaluation, and then expansion, and you could get really better quality content. So I'm going to test that from my framework. So if anyone wants to join, yeah.
Awesome.
go. So I guess our team, we have like a team of like 3 people right now. We're still looking for more people as for context. The overall idea of our project is to base it off of like stable diffusions and like somehow optimizing it much more for like human feedback. I feel like stable diffusions now isn't really
like the DPO mid-journey result.
Yeah, so we saw that paper. We saw that they did it like last week. So
Yeah.
now our idea is to, instead of using like LDMs, we're gonna do like LCMs, which are effectively like distilling the LDMs into using like LoRa and other stuff to make it like much more simple, like much more accessible, more computationally efficient. And I feel like, yeah, I think it would be a cool idea to try.
Yeah, it's super rich. Clearly there's like the possibility to create incredible image generators.
Yeah,
So,
I think it's especially because like, I feel like LDM has like a lot of parameters and then LCM could be smaller.
Cool.
Yeah, thank you.
Rohan, yeah,
Hey guys, so it's been like almost a year since like the first ideas around agents came out, and there's still not a single open source framework for us to like fine tune LLM agents in some kind of RL setup. Like, why can I not just take Llama and drop it into OpenAI Gym and like fine tune it for that kind of agent use case or environment? So today I'm going to be exploring, like literally just trying that, seeing if I can throw it in OpenAI Gym. There are actually a few NeurIPS papers that are exploring like RL fine tuning for LLM agents. So I'll take a look at those. But I wasn't able to find any like open source frameworks or like neat libraries for doing something like this. And then I think also maybe like next steps after this would be like actually use DPO for this. I know Raphael mentioned that you guys are doing agentive stuff with DPO, so it could be interesting, I imagine, to try setting up RL fine tuning with DPO or like LM fine tuning with DPO for agentive tasks.
Awesome.
Yeah, thanks.
Hi friends. So it's been like several years since I've been in academia, and I've been like, you know, in the startup grind set, and so I want to kind of return to that like academic vibe and explore something that I just haven't delved deep in. And the thing I'm really curious about is around combining traditional planning methodologies with LLM generation. So right now in LLMs, my understanding is there's like, you know, there's sampling methods for tokens, and then there's like, you know, you can do like a beam search, you can generate a bunch of outputs and then try to merge them in different ways. But the quality is not really, it's not the best. And then I've seen a few papers where like they've actually done state-of-the-art, say, code gen by doing like a Monte Carlo tree search on a portion of the search space that is like, but the problem with traditional planning, which I worked on for a bunch of years, like at Cruise and stuff, where you have this discretized space, you're like every intersection is a node, whatever. Those are great, but then they don't scale because like the search space is too complex. So you get stuck just basically being a parameter monkey who's like nudging things around. And hosting a lot of these hackathons here, I just like haven't, it's kind of just a vibe. Like I just haven't heard people talking about combining like the LLM kind of paradigm with like these more traditional methods. Like I don't think it's been given a lot of attention. I look at the papers that are published and like they don't come up in hackathons. So I kind of want to just like today find all of the projects that are doing that, do like a mini lit survey, and see if I could just really quickly like outperform like a state of the art. And so I've seen this happen before about a year ago or a couple years ago with like some friends and I outperformed the state of the art vision model like captioning task just by being like, can we just like train adapter layers and like we look at these papers like Magma and stuff and we're like, can we just like literally just based on intuition do something really dumb that could be done in a day, and like you might have a state of the art paper. So that's kind of my vibe. But so if you I think great teammates would be like, if you're really in the academic side and like you just think in papers, let me know. Yeah, thanks.
Okay. Are there any people who want to step up and impromptu give? Yeah, for sure. Casually create an alpaca.
Hi everyone, my name's Attendee. Earlier last year, I worked on alpaca farm series of stuff. Really happy to be here. I was inspired by Kyle's earlier questions to Raphael, like why he worked on DPO. And looking back for us, it's really out of desperation that I think everyone should be working on language models. and it was really, really hard to get human feedback. That's why we started this whole series of work with simulated preference, collecting preference from GPT-4, and so on. These days, I've been thinking more about agent and coding, code generation stuff. Happy to talk more with anyone who's interested in that here. Again, just want to say hi and introduce myself. Yeah.
All right. Hello, everybody. My name is Jonathan. So I worked a robotics job, first job after college, for about a year. My job was mainly simulation there. So I used Unreal Engine. If anyone's here has used that before, it's a fantastic gaming and visuals engine with a decent physics engine to back it as well. So one thing that I had to do there, has anyone heard of or used AirSim before? No? Basically, it's a plugin built on top of Unreal Engine that lets you simulate cars, drones, and really any robotic shape. So my robotics company wanted me to use AirSim to plug their custom robot model into Unreal and create simulated homes. So robotics people love this kind of stuff because you make a simulated home, you make a simulated robot, and now you have infinite training data. You keep generating homes, you keep getting images, whatever you need, and you can test your thing as well. So one thing we did is we'd generate a home, generate the robot, spawn it, and then have it drive around autonomously, see if it bumped into anything, see if it's identifying objects correctly and doing its job. So my job was to do this entire pipeline. And so what I realized was AirSim and Unreal Engine kind of had an inefficiency built into it. One that if you were to run it on a 2070 Ti GPU, which is a pretty good GPU, even if it worked on my nice 3090, I put it on there, it was too slow. So then I figured out a way to speed it up. It involved like speeding up the rendering pipeline, which obviously is, if anyone has ever done GPU code before, it's not easy, it takes some time. It took me a couple months to figure out. On the way, I used all the tools I had. I cloned Unreal Engine source code. I used Copilot. I used chat. I used everything I knew of. And they all just weren't up for the task because some code bases and some problems are just, they just take that much time. They take 3 months. But maybe they don't need to anymore. And that's what I want to look into. I want to see if some of the advancements that have come out recently can lead to, if I prompt it correctly, could it have led me down the track that led me to find the right kind of parts of Unreal Engine code base and the right changes to AirSim that sped it up so much. And so I really want to see if we could have cut that 3 months it took me down into 2 weeks or even a month. That's specifically what I want. So if anyone is interested, I know Ashwarya kind of had a similar idea. So yeah, for large code bases. So that is really specifically what I do. Like clone Unreal, take every tool we have and see, are we better, are we closer? And try to answer that question. So if anyone's interested, fine.
Any other from the hip? Yeah. I got 2 more. Yeah. Thank you.
Hi, I'm Shilo. I'm an independent researcher. I'm very interested in agents that conduct machine learning research autonomously. And this is not the main conference paper, but it's workshop paper. But I found a paper that proposed the benchmark to evaluate the capability of agents to conduct machine learning engineering tasks, and also proposed the baseline agents to conduct that task like cargo order. And I'm interested in extending that work or improve that work to do more human-like machine learning research. So I'm interested in doing something related to that here. I don't know what can I do in this short term, but yeah, I'm interested in that. And also I'm writing a position paper about the research agents for the ICML. So any feedback would be appreciated.
Amazing. Let's stop. Just so Vivian and I launched an autonomous research agent at one of the hackathons last year.
Hi everyone, I'm Archie. I'm generally interested in model, hardware, co-design things. So I've recently read the Mamba paper, if anyone's seen that, and it seems really cool. But it is hardware aware, and so they make some tricks to get it to run well on GPUs. I've been fascinated. I've also been looking to the MLX framework for Apple Silicon, and my idea was to first re-implement Mamba with MLX, and then as a follow-up, kind of see where, like, this is a different architecture, so you're gonna get different kinds of, like, I imagine that the performance isn't gonna be nearly as good, so kind of explore from there how to take advantage of Apple Silicon to make it better. Yeah, so that's my idea.
Yes. Comments?
Yo, what's good, guys? I'm Zane. I didn't really prepare this at all either. But what I'm really interested in is the whole process of like alignment. I think actually it's a UI problem, and I think we all should be contributing to the data sets that do the alignment. So like, I want to come up with some kind of UI where we can all contribute to the alignment data set, and then maybe use DPO to align open source models. So if anyone's interested in that, please come talk to me.
Hello everyone, I'm Tushar. So it's very unprepared, but I was wondering, again, the work is related to alignment, and we were wondering if we can use naturally occurring data sets instead of human-created preference data sets for creating alignment. For example, any forum or any place where human actually likes something and votes places like Twitter, Reddit, Quora, anything like that, and use that kind of data source and modify DPO, KTO for using naturally occurring aligned data from that source and play around with that. So you're welcome to join us.
Anyone else? Oh, yeah, for sure.
Yes, for me, it's not actually working on this, but I think it's an idea that's like really worth looking into, and I think it could both be really useful and also can be like a pretty significant business. Is I think we need to move towards the next stage beyond just alignment of text models. So I think if someone can create a platform and a UI that makes it really easy to collect feedback on things that go beyond text, so like things like music, text to speech, video, 3D shape generation, all those things that are now we're getting all these products that are coming out of the market of doing that, but they're not, they're still at this like stage 2 of instruction tuning, and they're all missing that final stage. And currently that there's no easy way to actually generate, collect, and collate and manage the data for that final feedback and alignment stage for all these sort of new generative models. And if someone can create a platform similar to like Chatbot Arena or something like that, it makes it really easy to collect and manage that data, either being even like in a paid format or being community supported. I think that's a huge need and a huge need that's currently missing, but also like a huge business opportunity.
Yeah, so yeah, we're doing that. What you just said, we're basically connecting all the applications into a namespace, and people are voting on what's the most useful stuff. So yeah, so if anyone wants to help work on that, we're doing that.
Okay. Thanks for all the patience. We're about to unleash all of you on your research projects, so exciting times. If you are here and you are not invited to the event, please leave quietly so that we don't have to ask you to leave. Appreciate it. And I guess if you're interested in compute, I will be setting up a system to give people access to GPUs. Zane of RunPod has been gracious enough to give us free credits. So if you have training as a part of your setup and you'd like machines, I'll be at this desk setting things up in the intro. Practically speaking, okay. The Hackspace is this floor and the 2 floors below. So if you haven't been here before, there's basically 6,500 square feet of Hackspace. It's massive. So feel free to use these floors. The bathroom's over here in the left-hand corner. Lunch is already at the kitchen, so avail yourselves, and we'll have dinner around 5. I'll be coming around to collect basically the projects that people have chosen to work on in 30 to 40 minutes once you guys have talked to all your potential collaborators and decided what to create. Anything else?
Yeah, one other point is if you need like on-site help, Gatsby, if you want to raise your hand, Gatsby's helping with a lot of like the on-site today, just like the toilet paper is out, the whatever is not working. She'll be available, and thanks so much for helping bring the food in and everything. Yeah, and obviously you can hit Jeremy and I up for anything else. Cool.
Okay. So basically, this is an incredible opportunity. There are very few rooms that have this much distance between an idea in your head and a launching product. So basically, it's up to you to figure out whether or not research hackathons are possible. Do your best, find a bunch of creative collaborators, launch your vision, your dream into existence in 7 hours at 8 o'clock. And with that, let the NeurIPS Research Hackathon commence.
सही बच्चों को ज़्यादा कुछ किया है ये तो बहुत इजी हो गया खाली हो गया was here, now she's gone. Jeremy? Hi. Turn this off? Oh, yeah.